Hello and welcome to another episode of Alpha Audio. Today we're not going to look at some new products. It's actually a video about the difference between two products because it was quite fascinating when I started measuring them. This is not a video about measurements. It's more like a video about the differences I noticed during the measurements. So it's not going to be a really techy video anyway. It's more like what is the difference and how do you apply these products. Well, that was quite a cliffhanger. I'm sorry. We're going to discuss the Isotek Syncro Evo 3 and the Isotek Gemini Evo 3 as well. And these are two very different products. Well, most of all, this one has two outlets and this one has only one outlet. People that already know what the products are will probably say, yeah, well, this is a filter and this is a DC killer. And yeah, it's true actually, but the way you apply them is different. This one is to get rid of DC problems in the grid. And DC is direct current and our grid is alternating current, AC. And mainly products with linear power supplies, with toroidal power supplies, don't like direct current. Mostly going into the product. Because if you get DC into your toroidal transformer, it will create a magnetic field and you get resonances. And that resonance is hum. It's like in your amplifier mostly, because it's mostly an influence that you get with bigger power supplies. And probably people with older amplifiers with big, huge toroidal transformers notice this problem. They know the hum in a product, and that's created by DC offset. Well, this Isotek product will get rid of the DC. Well, mostly get rid of the DC. It will solve sort of the problem, and it works, definitely. This Isotek Gemini is actually just a filter. I think it's like an ISO plug in a decent built distribution block. You can combine these two without any problems, and actually Isotek says, you know what, you put this near the wall, you pick a power cord, you plug it in, and then you can use any distribution block you like. That's how you actually use this product. What I noticed during the measurements is that this actually measures pretty bad if you look at it from a filter perspective. I tried to measure it on our AC generator, and you can set a DC offset, and you can look at the sine waves in the picoscope software, and you can look at all sorts of stuff. But I kept getting worse performance than directly from the grid. So I measure the grid or the AC generator and you get a baseline, and then I use this in between the generator or the grid itself, and then I probe the outlet. And every time I looked, this outlet was worse. Then I started calling, and they said, yeah, well, it's normal because there are some diodes inside, and you get some capacitors to filter out the DC, and it fixes the sine wave structure, etc., etc. Like I said, it's not going to be a very technical video, and it actually makes sense because what it actually does is kill DC to prevent DC from getting into your power supply. And you can do it with diodes, and if you use diodes or some sort of layout with diodes, you need to fill in the gaps, and that's what the capacitor bank does. It has a small capacitor bank inside as well to create a nice fluid sine wave. But in the end, the measured performance of the grid versus this is worse. But it still sounds a lot better because your power supply has less stress, so to say. And it doesn't really matter what the distortion on the grid is, because or the shape of the sine wave, because in the end the power supply will rectify it anyway. It makes AC into DC, and there's a capacitor bank at the end of your power supply as well. So that doesn't really matter. What does matter is all sorts of noise, high frequency noise, low frequency noise, etc., etc. This is not a filter. And that's what I noticed as well, because if I put in some noise, the same noise will get out. A little bit less, of course, because it has some capacitors and some and a small filter inside, but this filters a lot more actually. I noticed a very obvious filter slope when I injected white noise, for example, or any stuff like that. But this doesn't do anything with DC. So you can imagine that the effect of the Isotek Gemini or the Isotek Syncro is very different. Both did increase the stereo image and did in fact bring calmness. What this doesn't do, or what this is not suitable for, is devices with switch mode power supplies, because switch mode power supplies don't care about DC. So don't buy this for your streamer with a switch mode power supply, or your amplifier with a switch mode power supply. It doesn't make any sense actually. This you can use because practically every switch mode power supply throws back some junk on the grid. And if you use a switch mode power supply in the same distribution block as your other devices with a linear power supply, for example, you can actually pollute those devices. And a lot of people don't think about that, but that's how it actually works. And this will isolate your switch mode power supply noise from the rest of your equipment. This doesn't. This is purely for DC fix stuff. That's not English. This is purely for fixing DC stuff. So with that said, I'm not going to publish any measurements from this device because it doesn't make any sense. I need to do some extra measurements if I find the time by combining a power supply that I feed with and without this device. Otherwise I won't see the difference. Well, I learned a lot from playing around with this kind of stuff. It's very different from what I'm used to, but it was really interesting. And I hope you find it interesting that I actually told you the difference between these two devices, because I didn't really have any DC fixed devices in my hands up until now. So I found it really interesting to play around with it. Hope you liked this video. Thank you for watching. See you next time. Bye bye.